Hello everyone. This video is a continuation as part of our DC transformation series where we are discussing the network migration architectures and planning related to network cutover. We briefly looked at the IP retention requirements for the servers after migration, and that results in VLAN extension requirements between source and target data centers in previous video. In this video, we will take a much closer look at the various layer 2 stretch or VLAN extension solutions available and why such solutions are needed, where are they need to be considered, and how do you make a network level design decision. How do you select an optimal layer 2 solution for your migration requirement, considering various pros and cons of each option. I hope all these questions will be clarified at the end of this video. You would have seen this slide in the previous video where we discussed two different migration design scenarios, one in which server or the application addresses are changed, and the other one, the same IPs will need to be retained in the target infrastructure. I'm providing the link for this video in case you want to have a look at it. Both scenarios have their pros and cons, but let's look at the requirements or prerequisites the second option has, which is the requirement of layer 2 extension solution between source and target networks. That's the only way for the servers to retain the IPs in the target when there are still active IPs in the same subnet in source. Assuming the scenario where it is not possible to move all those servers within a VLAN or a subnet together in the same migration window, and as you know, gateway cutover cannot be done in halfway. Hence the need for VLAN extension. As I mentioned before, in this approach, you need to consider the migration as complete only when the network cutover is complete and all the VLAN extensions are removed. Let me try to detail the same with this animation. This should make it clear to you that why VLAN needs to be stretched across source and target networks and how the traffic flows with such solution in place during migration. It's a similar migration example as shown in our previous video. What you see is a source and target DCs in left and right respectively. There is just one subnet or a VLAN configured in a router, and there are few VMs attached to that subnet. While preparing the target for migration, there is a router deployed and the same VLAN subnet is configured in the target as well. And notice that there is no gateway enabled yet. In this example, not all the servers are migrated in the same window. This means that those few servers which are moved to the target need to access the gateway, but as you know, you can't have the same gateway address and same subnet in both locations actively at the same time. So how do these migrated servers use the same IP address used in source and have access to the same gateway in source? Only way is to stretch the VLAN from source till target network and expanding the broadcast domain or the VLAN. This enables the migrated servers to access their gateway and connectivity to the servers in the same VLAN in layer 2. This means that any traffic towards the migrated server will always flow through the source data center even though servers are residing in target data center. Once all the servers are moved out of the source network, you would initiate the network cutover process. You would disable the gateway in the source first and then enable the same address in the target router as the gateway for the migrated servers. Once the gateway is locally enabled in the target, advertise the specific network prefix from the target network. But till this network cutover execution, source DC will continue to own the respective subnet and traffic flow is always dependent on the source network infrastructure and VLAN stretch setup. So that is a crucial point wherein all the migrated servers are totally dependent on the VLAN stretch setup. Now I hope I made the why do we need such solution apparent to you. Let's look at some of the design options available. So this is not everything, but hopefully this will give you a better picture of available and widely used L2 stretch options. This can be classified into three different types based on the type of underlay service we get from the provider. What I mean is that when you need to connect two different locations with some type of physical connectivity, you are dependent on an external service provider. Then using such physical connectivity, which is the underlay, you can configure to extend your layer 2 over this depending on the type of the link. Let's discuss the layer 1 connectivity type. wherein we establish a physical layer 1 connectivity between source and target DCs. And we can use it to transport Ethernet layer 2 protocols or any layer 2 protocols for that matter. But our requirement here is to enable .NQ VLAN trunking protocol over these links. In simple terms, it is as good as connecting two switches with a cable and stretch the VLANs across using a .NQ trunking. One such widely used and popular option is the dark fiber links. These services are offered by providers using some type of multiplexers like DWDM solutions. Then we have layer 2 type of services. The way service provider offered a layer 1 connectivity in the previous case, here service providers can offer such layer 2 connectivity directly over the WAN. And on a side note, hope you know the usual MPLS service, what we get is layer 3, right? So the service providers implement Ethernet services using several methods on their network. MPLS networks support Ethernet over MPLS and virtual private LAN service or VPLS. Also, Metro Ethernet can provide layer 2 Ethernet service, but in a smaller geographic area. Any such WAN service can be used depends on the design requirement and based on the availability in the respective locations, whether as a point-to-point or a multi-point service, where you can connect 2 or more LANs and trunk the required VLANs directly to extend to other sites. Then the third option, which is a layer 3 service. Service providers deliver such services based on IP or MPLS. Contrary to the previous options, you can't natively use the layer 2 protocols here. Hence, we need to establish some sort of overlay network and extend the VLAN or layer 2 on top of it. Some of the popular choices are VXLAN, OTV, and layer 2 VPNs. Each protocol functionality is a topic on its own, but at a high level, all of these protocols will simply encapsulate the layer 2 frames in the source site using the respective overlay headers with the new layer 3, layer 4 information and send it to the other site. Those switches in the target site will decapsulate or de-encapsulate the packets and then forwards as a layer 2 frame to the right endpoint. So this is how the L2 is extended across layer 3 boundary using any of such overlay solutions in a very high level. Having understood some of the popular choices and widely used options, let's look at the pros and cons of each design option we discussed now. Layer 1 services like dark fiber links are easy to configure and implement in the network devices. You can achieve higher throughput since you get high bandwidth and dedicated physical connectivity. You also need to consider whether service providers use DWDM platforms to terminate the dark fibers and provide the Ethernet connectivity towards their LAN network, or you want to terminate the dark fiber links directly in the LAN switches. Depending on that, either you need to invest in service providers or procure the compatible fiber transceivers for your switches. Both are viable options, by the way. Some of the cons could be dark fiber links tend to be expensive compared to the other options. Also, they may have constraints related to long distance requirements. You always need to check the feasibility with the service providers on such services before finalizing this as a solution. About layer 2 WAN services, I have not used or seen these for migration purposes. We used this as a solution for specific WAN connectivity requirements, but never in a migration. The obvious advantage over the first option is that this could be cheaper and network side configuration can be simpler, just like the option 1. Since you get the native layer 2 from the provider, you can choose to stretch the VLANs through these links directly. Cons would be the availability of layer 2 WAN services in all the locations from these service providers. And it's not like the dedicated point-to-point service as dark fiber, hence performance may be comparatively lower than the option 1. And the final option, layer 3 service. As we had seen in previous slide, we need to establish an overlay network on top of the layer 3 WAN network. This is an advantage compared to the other options. You can get any IP MPLS based network as an underlay and build your own overlay solution using VXLAN or OTV kind of protocols. This carries an advantage of being provider independent solution, also cheaper than dark fiber services, but you also need to take the cost of the overlay solution into account. Since you need to build a new overlay solution that is complex than previous options, and this will take more effort and time in planning and building. As I said in previous session, migration scenarios and requirements are always unique in nature. We may have to create a solution and make design choices based on those specific requirements and constraints. Let's look at few design decisions for understanding purpose on the options we discussed till now. Let's say that, for example, we need to establish the layer 2 extension between two DCs, which are 100 kilometers apart from each other. There is a huge volume of data to be migrated, like few terabytes of data between these DCs. And the migration timelines are very aggressive, which means you need a large and dedicated pipe for migration. And since DCs are closer, like it's about 2 millisecond round trip latency, we can choose the dark fiber based connectivity in this case if it is feasible. In longer distance DCs, where service provider dependent options are not feasible and you still need a layer 2, you can go with overlay solution on top of any layer 3 service. Keep in mind, timelines and budget play a major role in choosing the link type as well. It is crucial that all the stakeholders part of the migration are aware of the risks carried due to layer 2 extensions. When you stretch a VLAN across DCs, basically you increase the blast radius or failure domain. It is always recommended to have layer 2 within a LAN in an access layer in the smallest radius as possible. Broadcast storms and spanning tree loops are some of the examples which can bring down the entire network if the network is not configured or designed properly. And of course, troubleshooting will be hard due to several VLAN stretches, and of course when the overlay solutions are involved. Due to layer 2 stretches, migrated servers will always reach back to the source, as we had seen in the animation before. This traffic harping may impact the performance of the application. This risk will exist till the network cutover happens. I hope this high-level information on layer 2 extension network design would have given you a better clarity for your migration planning. As usual, thank you for watching and good luck.